Guys, come on, let's provide a solution to this problem. We have an interesting exponential expression from Harvard University entrance exam math problem. 2 to the power of 54 plus 1 all upon 2 to the power of 27 plus 2 to the power of 14 plus 1. And we have to do this by calculator. Hence, we need to think outside the box. The first thing we shall do is to make do with an algebraic substitution. If I say let y equal to 2 to the power of 14, with this, I can then simplify 2 to the power of 27 and 2 to the power of 54. We shall start with 2 to the power of 27. So this is the same thing as 2 to the power of 28 minus 1. Now, from the division rule of exponents, if I have a to the m all upon a to the n, so this can be simplified as a to the power of m minus n. Hence, if I am giving a to the power of m minus n, I can devolve it into a to the power of m all upon a to the power of n. So we can then write this as 2 to the power of 28 all upon 2 to the power of 1. And anything raised to the power of 1 is the same. So we can then write 2 to the power of 28 in terms of 2 to the power of 14. So we are going to have 2 to the power of 14 whole square all upon 2. Now here, from the power rule of exponents, if we have a power raised to another power, we multiply the powers. So 14 times 2 is 28. Nothing has been altered. So this is actually y squared all upon 2, because y is 2 to the power of 14. So similarly, we can then do for 2 to the power of 54, which can be written as 2 to the power of 56 minus 2. If we do the same thing, we are going to be having 2 to the power of 56 all upon 2 squared. Then I can also write 2 to the power of 56 in terms of 2 to the power of 14. So that's going to be 2 to the power of 14 raised to the power of 4 all upon 4. And again, 2 to the power of 14 is y. So this is going to give us y to the 4th all upon 4. Now, in the expression, in place of 2 to the power of 27, we shall solve y squared upon 2. In the same vein, in the place of 2 to the power of 54, we shall solve y to the 4th all upon 4. So we are then going to be having y to the 4th all upon 4 plus 1 on the numerator. Then for the denominator, okay, 2 to the power of 27, that's y squared upon 2. All right, y squared upon 2 to the power of 14, that's y. I will write y, then plus 1. The next thing I shall do is to multiply everything on the numerator by, and denominator by 4. And we shall do that. So if I multiply, that would be 4 multiply y to the 4th all upon 4 plus 4 times 1, that's 4, all upon 4 multiply y squared upon 2, then plus 4 multiply y, which is 4y, then plus 4 multiply 1, which is 4. So 4 will cancel out here. 2 we divide it into 4, we have 2. So that this expression becomes y to the 4th plus 4 all upon 2y squared, 2 multiply y squared here, then plus 4y plus 4. Now, the next thing we shall do is to find a way to factorize the numerator. And we shall do that by using Simon's favorite factoring technique. So what I'm going to do is this. I'm going to ensure that I write the numerator as a perfect square trinomial and the difference of two squares. So if I decide to write y to the 4th plus 4y squared plus 4 minus 4y squared. I have not altered anything on the numerator, in the sense that 4y squared minus 4y squared is actually 0. So all upon 2y squared plus 4y plus 4. So y to the fourth plus 4y squared plus 4, that's actually a perfect square trinomial. Then 4y squared is a perfect square as well, which is 2y whole squared. So I can then factorize this to become, okay, let me take out this part of the board. So I can then factorize this as y squared plus 2 whole squared, like I said. Then 4y squared is a perfect square, which is 2y minus 2y whole squared. Okay, 4y squared is a perfect square, okay, which is 2y whole squared. Then all upon 2y squared plus 4y plus 4. Then, again, on the numerator, we have a difference of 2 squares. So y squared plus 2 whole squared minus 2y whole squared. And we are very familiar with that formula. If we have a squared minus b squared, we can write this as a plus b multiply a minus b. Now, with this algebraic identity, I shall then rewrite our numerator. We are then going to be having y squared. Our a is actually, in this problem, a is y squared plus 2, b is 2y. So if I add a plus b, that becomes y squared plus 2 plus 2y in one parenthesis. In the other parenthesis, I'll be having y squared plus 2 minus 2y, everything upon 2y squared plus 4y plus 4. The next thing I'm going to do is to clean this up. I'll write y squared followed by 2y. So we have y squared plus 2y plus 2 in one parenthesis multiplied y squared minus 2y plus 2 in the second parenthesis, all upon 2y squared plus 4y plus 4. Now, instead of writing 2y squared plus 4y plus 4, I can actually factorize. If I factor out 2, I'm going to be having 2. If I use 2 to divide 2y squared is left. If I use 2 to divide 4y, that gives me 2y. If I use 2 to divide into 4, that will give me 2. So as you can see, this entire expression on the numerator will take out this. So we are left with y squared minus 2y plus 2 all upon 2. So I'll take this off. So we are left with y squared minus 2y plus 2 all upon 2. So if I divide every term on the numerator by 2, we are going to be having y squared upon 2 minus 2y upon 2 plus 2 upon 2. So this is going to give us y squared upon 2, so minus y plus 1. Now, y squared upon 2, that should be 2 to the power of 27 along the line. Then y is 2 to the power of 14. We write minus 2 to the power of 14 plus 1. So I can actually factorize this. So if I factor 2 to the power of 14 out, we are going to be having 2 to the power of 14. If I then use 2 to the power of 14 to divide into 2 to the power of 27, using division rule, that becomes 2 to the power of 27 minus 14, which is 2 to the power of 13. We are going to be having 2 to the power of 13. Then, okay, if I use 2 to the power of 14 to divide into 2 to the power of 14, that becomes 1. So plus 1. So guys, if you do the arithmetic here, which is doable, we are going to be having 134 million 201,344 as our final answer. So guys, we are done with today's tutorial. Please hence make sure you like and share this video, and don't forget to comment and subscribe for more. See you next time and stay blessed.